Okay, good morning, everyone. I'm your host for today. Our topic is ground to orbit hacking, 5G, and satellites. If you face any technical issues, feel free to message in the chat box. We also have parked 10 minutes after the presentation for a question and answer session. This is a recorded session, and we will upload the recording after the webinar. Thank you, and over to you guys.
Hi, everyone. So first, let's present ourselves. So I'm Frederic. I'm a cybersecurity engineer at VisionSpace. VisionSpace, what we do is essentially solutions for space and defense projects. We offer services as penetration testing, vulnerability assessment, and red teaming against ground networks, mission control, and onboard software. As for myself, I've been doing offensive security research against onboard and mission control software, and also developing training content that can help you secure your operation. And here today is with me is Andrew, our colleague.
Yeah, my name is Angel Fava. I'm a cybersecurity engineer working at VisionSpace. I've been in space industry since more than 15 years, and since last 2-3 years, I've been focused on vulnerability research and exploit development in space systems. I have been credited with around 40 CVEs up until now, and I'm also co-author of the Spacecraft hacking handbook.
Hello, everyone. My name is Pavel Novikov. I'm from SecurityGen, and more than 11 years I'm in telecom security industry. So I'm head of telecom security and research and delivery in SecurityGen. Focused on different parts of mobile network like radio access network, VoLTE, voice over Wi-Fi, TTP diameter, 5G, and so on. So also I'm a co-author of GSMA FS20 document, which is about GPRS standard and protocol security. Okay, over to you, Ricardo.
So a bit about what we're here for today. First, we'll have a short introduction to 5G and how it connects to space. Then a bit on how 3GPP networks should work from space when everything goes right. Then shift a bit into threat vectors and how they can break, and a couple of demos on showing when that space segment can break and how, and a bit of defense strategies that you could use to avoid it, and then any questions that you might have. So first, for our introduction, typically when we hear about 5G and telecommunications, our immediate thoughts might be about the high-tech rectangle that we have in our pocket, and basically how these connect ground networks for communication. But communication goes beyond the planet's surface, and that can include anything from satellite constellations and non-terrestrial networks, and much more. But first, we need to take a look back at how we got to this stage. So if we look at the number of satellites launched to low Earth orbit per year, what we see is that they had a huge increase in the 80s, mainly driven by the Cold War, and these were used for space observation and communication, but then that decreased around the 2000 year. However, if we look at the last decade, we see a huge increase on launches and constellations. This has been primarily driven by commercial applications with constellations like Starlink, but also OneWeb, amongst others. And this extra capacity is being put to use. So basically what we have here is a short list of examples of partnerships between telecommunication operators and satellite and NTN operator across different continents. What we see there is the number of mobile connections in the millions, and the main disadvantage is that most companies are using this to increase their direct-to-cell capability. And this is not just theoretical. We already see this shaping day-to-day operations. With just December last year, we had the world's first direct 5G connection to a LEO satellite with ESA, and just after that, we had Eutelsat with Airbus and MediaTek launching the first 5G network trial. And just June this year, we saw T-Mobile in conjunction with Starlink launching their direct to mobile service. So what we see here is the rapid increase in direct-to-cell capacity across multiple regions, but also a huge increase in the attack surface. So basically, every time you had a new device or a new satellite to your network, you're increasing the attack surface and the potential attack vector, increasing the risk for your operation. So if we talk about increased attack surface, we obviously need to talk about the Viasat incident. That was at the onset of the Russian invasion of Ukraine. Just a day before, they launched a cyber attack against Viasat that turned down tens of thousands of modems. This had a huge impact across operation in multiple countries, has been talked extensively over the last years as one of the largest attacks on space infrastructure. But not only that, that kept going until today. We see an increase in GPS spoofing attacks in the region, mainly ground-based local spoofers, but still affecting operations. But even other threat vectors and threat actors. So, for example, we have TRIP that has been targeting United States and Southeast Asia. This has been specifically targeting satellite and telecommunication companies and operations with different motives. But not only that, even just this month, we saw research published that with relatively inexpensive equipment, these researchers were capable of capturing unencrypted data from satellite links. This included everything from backhaul traffic to industrial control system information, military asset tracking, and in-flight Wi-Fi. So basically, it's not super complex or super expensive to build this type of targeted attack. So, but first, let's talk a bit more about how these networks should work from space when everything is done right. So, not too Bible.
So, yep. So yeah, let's describe how this mobile network should work actually from space. And so generally, the first question is why this idea not came before, because previously the communication from satellites and from space is not something new. There was some kind of proprietary phones and stacks and satellites which were allowing you to use voice or even sending messages or even data from space. But this requires some specific terminals to be handled by user. It costs not cheap, so that's why it seems kind of good idea, like to try to do this using those phones which are on hand in most of people. So the idea looks brilliant. But if we look on technical limitation, there is a different problems related to that. So I will not try even to explain all these issues which are related to this communication, but I will just highlight some few of them, like HARQ, for example. This is something similar to TCP retransmission, but in LTE and 5G network. And also there are some issues with timing advance, which I explain on the next slide. So there are also other issues which you can see on the slides. I will not go deep in all of them, just only one of them. So, for example, if you are looking on terrestrial network, so there is a base station, and the problem is that different user equipment, different phones are located on different distance from base station, and it means that we have light speed, and due to that, packets from this phone, from UE number 2, will come to base station faster than packets from UE number 1, because it's located a bit far from base station. So that's why to make it possible for base station to receive all the data in some specific times. So this is time when it is expected to receive by base station some packets from some subscribers. So this subscriber need actually to send this message somehow heard this time. So phone need to transmit his packets a bit earlier than it should be expected by base station. And this issue called, not issue, but how it's solved in terrestrial network, there are time in advance unit. And for example, in GSM, there are each time in advance unit belongs to 550 meters. And the maximum number of TA is 63. So the longest distance, which is capable for GSM network, it's a bit less than 35 kilometers. So even on the newer generation of the networks, there are the same problem, like there is only 100 kilometers for LTE and a bit more, 3 times more for 5G, so 300 kilometers possible maximum distance from subscriber to base station. But if you look on different options of non-terrestrial network, especially if you are talking about satellite communication, so we can see that even a low Earth orbit, so it is starting from 500 kilometers from Earth. So it seems that it is not possible to run it out of the box. So just launch 5G or even other G base station in the space and it will work. It will not work because of technical limitation. So, but there are some work in 3GPP consortium who is working on standards for all generation of the networks, and they invented two main way how to transmit a mobile network from satellite. So, and first one of this, it's called non-regenerative payload, and it means that if operator have core network on the ground, radio infrastructure also on the ground, and then there should be some transmitter which send this to the satellite, and satellite kind of works as a repeater to transmit it on the Earth to reach some subscriber on the Earth. And next option is different one. It's called regenerative payload, and the difference is that core network is on the ground as usual, so it will be located somewhere in data center. But radio access infrastructure will be on satellite. So literally, we launch base station on the space, and there will be some connection between this base station and the space radio access network by some ground transmitter. And then it will work like usual base station on terrestrial network. So if we go to the next slide, we see that this work about standardization of space communication started not today, but more than 5 years ago. So initial work was started in release 15, which started in 2019. And this was not kind of ready. It was like, what if we will launch base station in space? And then there was work regarding that. And only in release 17, there was first release with normative requirements for non-terrestrial network in 3GPP. So it's 2022, and only transparent payload was supported by it. Nowadays, so there is release 19, which is released 1 month ago only, and so finally it supports even regenerative payload. So this is the way how we come to this particular point when it is possible to establish communication from space. Also, you can see that 3GPP allocated some specific specific bands for this communication via satellite, because transmitting usual bands of 5G LTE bands is not possible, mostly by regulatory issues, because for each country it should be separate license and so on. So that's why, probably that's why they allocated some specific bands for this communication. Now let's speak about threat vectors, which is related to telco-specific infrastructure and this option of deployment. So probably you were able to see on some initial slides, which were shared by Ricardo, that already some operators are working with some of satellite providers like Starlink and so on, but it's clear that these space satellites will be owned by one company, and most probably it will be not mobile network operators. So that means that many mobile network operators will be connected to this infrastructure, to this satellite connection, and somehow they will be connected between each other from unexpected way. So because usually networks should not be connected by this from this side of the network, but here it becomes possible. And for example, if sometimes operators doing well, not sometimes, definitely every operator have their own configuration of mobile connection, and some operators allocate to subscriber kind of public IP addresses for connection, and it means that probably you know that in internet every IP address is scanned 1,000 times per minute by different crawlers, hackers, and some researchers, and so on. So all this garbage traffic will go from some operator, while all this long chain to the subscriber. And as a result, it will drain bandwidth of for all these operators and for satellite communication just because of that. And also it will increase battery drain of subscriber phone, because satellite communication is kind of requires enough power to do that. Another option is with regenerative payload. This is more promising from attacker point of view, at least from telecom focused attacker point of view, because this is kind of 5G radio infrastructure in the space. It means that core network on the ground and 5G radio on the space. And if you somehow able to hack this for 5G radio, so you can even establish fake satellite BTS. So there are some issues in mobile network like IMSI-catchers, known like IMSI-catchers or fake BTS. They have different possibility on different generation, but still it's present for every generation. So even for 5G, it's still possible due to architecture of mobile network. So if you look on usual 5G core infrastructure, so there will be a piece of network functions which are located in a data center, and usually here should be a GNLB base station for 5G. But now in this case there will be a GNLB on the satellite, and no significant difference from operator point of view for that. So that's why there are some issues may be achieved even from satellite, which was possible from usual terrestrial network. And one more important thing is about location, because there are multiple vulnerabilities which lead to subscriber location disclosure. So if you have access to some specific network, which is kind of easy, not easy, but it's possible to achieve, So you are able to get location of some specific subscriber. And if you are talking about usual terrestrial network, so this location will be quite not precise. So it's around maybe kilometer or something like that. But and because it is not required to have precise location for a mobile network, for terrestrial mobile network. But if you are speaking about non-terrestrial network and broadcasting from satellite, network and satellite should know your precise location to do this communication, because satellite should do some proper beamforming and so on. And it means that in every second, network and satellite will know your precise location precisely by several meters. So this may be a horror of paranoids, because this is screenshot from Wireshark, where location is disclosed, so you will see that it will be precise in GPS coordinates. Unlikely it happens in terrestrial network, where it is not precise. And this is the description of how to do this attack in 5G, for example. This is confirmed threat vector. So if we are able to kind of get some specific access, and we are able to establish rogue network function, for example, UDM on this slide, so and send some request via HTTP2. So we will receive subscriber location of subscriber. So, yep, it is possible. And other things are also possible. For example, we also know about some vulnerabilities in 5G, which may lead to denial service. The idea that some messages which can be sent from core network, they come to some device called AMF, and then AMF will encapsulate our payload, which we send via this HTTP2 request, and send it to GNode B, which will be sent directly to the phone. So this is a way how we can somehow manipulate of subscriber via subscriber connection. And the easiest attack, it makes denial service. So this is kind of easy how to craft such method, which will lead to denial service attack on the subscriber. And one more point, I already highlighted it before about IMSI-catchers. So on the ground, if you're talking about terrestrial network, there are problems like, so if you have legal GSM network and subscriber connected to this legal GSM network, attacker may deploy his own base station with some specific configuration, but it is not hard to configure, which will allow to intercept subscriber to this fake BTS. There are different options. For example, in 2G, this fake BTS may do whatever is possible in mobile network. For example, send an SMS, do fake calls, and so on to the subscriber. In latest generation, the possibility is less, but it's still possible to obtain IMSI, which is kind of quite sensitive identity of subscriber, which is stored in SIM card and never changed. So looking on that, it means that if someone will be able to penetrate here to 5G base station, he can establish fake BTS from satellite, which will be able to intercept, for example, subscribers from whole country or from whole European Union or something like that, because network coverage for space communication is much bigger than for terrestrial network, because when attacker deploy fake BTS from on the ground, usually it can cover several kilometers, not more. But if it is possible to do it from space, it becomes kind of much more kind of issue becomes much bigger. So, and next problem, which we can highlight that mobile network can request sensitive information like IMSI, even in some legal situation. For example, when subscriber connected first time to the network, or it lost connection in some one place and then appeared in another place, then network may request IMSI of subscriber in clear text. It means that if such communication will be done from the space, so it will be visible for everyone under coverage of this satellite. So yeah, because in terrestrial network, again, the coverage is about few kilometers. So, and if you install these antennas, you can intercept this IMSI just of subscriber just around you. But if you're talking about satellite communication, this IMSI will be sent to much bigger area, and it is possible to intercept it in passive mode. Even that, from our experience, we see that some mobile operators doing something in the wrong way because of wrong configuration, and they may request IMSI even every connection. For example, you're sending SMS, and they request your IMSI. You are making calls, they request your IMSI. So it means that this identity, which should be kind of sensitive, should not be disclosed unnecessarily. It will be disclosed not only unnecessarily, but also for very wide area, and it is possible to intercept it in passive mode. It was telecom-specific threats, and now I'm passing word to Ricardo about satellite-specific threat vectors.
Thank you, Pavel. So yeah, we'll talk a bit about satellite-specific threats. Before we delve too much into that, we need to understand how the space systems work. So first, we can obviously have a spacecraft or multiple if you have a constellation. That's your spacecraft flying on space. To talk to this and to control it, we need our ground segment, here represented by ground station antenna. This includes all the terrestrial infrastructure that supports a space mission. It can also be mission control center, fiber networks, and your typical IT infrastructure that's required. The list goes on. And finally, the user segment, that is what comes out of the mission. Can be user terminals or your own infrastructure. This is essentially where the data comes out from your mission. So as an example, it will look like this. You'll have your spacecraft in orbit. This is communicating over a radio frequency link with a ground station. That ground station is linked to a mission control center that distributes your the processes and distributes the information to data center or your core network. And from there, then it's shifted into the end user or supplied to the end user. Obviously, this needs to be controlled by someone. These are not fully automated. And so you need teams 24/7 to working on operations to keep your mission operating and functioning. Those are the spacecraft operators there. Typically, this would be based around perimeter security. So you'd need physical access to a certain location to control it. Now, and especially since COVID, that's no longer the case. These systems are being more and more exposed to the internet and new threats just because they need external communication. So we first focused on targeting two locations. First, the mission control center. This can be considered the heart of the mission. It's has a wide IT infrastructure. There's a lot of custom software and automation built into these operations. You can have your astrodynamic software there to determine where your satellite is and where it will be. Mission planning software that accounts for the next steps based on other inputs. and mission control software. That's the thing that's used by spacecraft operators to actually control the spacecraft. It's your human-machine interface. So in this context, we focus our research on open source software with that purpose. We looked at YMCS that's used in a number of smaller satellite missions, but also planned to be used in lunar rovers, and it's currently used for to control the European robotic arm of the ISS. Also NASA's OpenMCT that's used to control the Mars rover, and OpenC3 Cosmos that's been gaining popularity among smaller satellite missions. And also looking at the other side, onboard software, that you can think of it essentially as the operative system of your satellite. We focus on frameworks that can be reused between missions, and so they affect multiple targets and operations. We focused on co-flight system, or CFS for short. That's used in small satellite missions and has already multiple decades of legacy. It's being used on the James Webb Space Telescope and being qualified for human spaceflight, but also F-Prime, that's a smaller network that was used in the Ingenuity Mars helicopter, but it's also built so that it can be reused across multiple operations. And what we found is that if you think about destroying a satellite, usually what you expect is you throw a missile at it and physically destroy it. That is capability that's already demonstrated by multiple nations, but has a huge negative impact on operations. Essentially, you contaminate the space area with debris, and there's all sorts of negative effects. And what we found is that it's much easier than that. You can essentially target the software that's running on that mission. Basically, there's a lot of software that has a lot of legacy. This was traditionally not designed with security in mind. They didn't have the security requirements that we have today. So it was never meant to be exposed to the internet or to the different threats that we find now. And so next, my colleague Andy will show you some of the stuff that we found and how they can actually be used to take down your missions.
Okay, so let me share my screen now. Okay, so thanks, Ricardo. What we'll see now is a couple of demonstrations showing different vulnerabilities, attack vectors, and exploitation techniques. Obviously, in the end, what we want is to eventually take over control of either a spacecraft directly or the system that is controlling such spacecraft. Just to reiterate, the mission control system is at the heart of every spacecraft operations. And I thought that in this presentation, I'll focus on demonstrating these specific systems. In the first demo, we'll focus on OpenC3, which Ricardo mentioned before as the mission control system, and how we could use one of the XSS vulnerabilities to take over the entire system that monitors and controls spacecraft. To do that, we'll need to target, well, because it's an XSS and it's in the URL, we will need to target one of the users with a phishing campaign, which is quite realistic, in order to trigger the vulnerability, and that should give us, hopefully, a reverse shell back to the system that is controlling the spacecraft. So I will switch now to the virtual machine. It's gonna be live demo, so let's hope it works. I'm gonna start the OpenC3. So this is how OpenC3 mission control system looks like. It has all the basic functionalities that you might expect from any mission control system, which is telemetry and telecommand handling, so you can receive telemetry and process it. You can send telecommands to spacecraft. You can connect to different ground stations through which the communication actually goes. It also handles the data. It has some additional functionalities to extend the base functionality, like in case of OpenC3, there is like a script runner, which you can define Python and I think Ruby scripts, and of course documentation and so on. So this, among other vulnerabilities, this version of OpenC3 Cosmos is vulnerable to unXSS, which when triggered can give us reverse shell. The exploitation is a multi-stage exploitation, which means that in order to pull this off, there are a number of calls made to the API. One is to steal the session tokens, because there's also authentication mechanism in between, and then to deploy malicious script and then eventually to trigger it. So it's a combination of actions that needs to take place. So to make our life easier, we have developed a simple script that generates malicious URL with a command or Unix command of our choosing. And in our case, because we want to get a reverse shell, we just generate this command. So this is our payload, which we are going to use to target our users. Let me quickly start the shell, the netcat listener. So let's say I'm a poor user that has fall for the phishing campaign, and I clicked on the link. So from my perspective, from the user perspective, nothing has happened. It looks like I entered the system, but if you look in the background, we have just received the reverse shell back to the system that effectively is controlling the spacecraft. So that was the first demo. Let me quickly prepare the second one. In the meantime, I'll share my slides again. Okay, so that was demo number one, where we took over control of the entire system. So the question is, once you have access to the system, either the mission control system or the system that is used as the infrastructure, what you can actually do with the spacecraft. So this is something we'll actually address in this demo. In this case, we are gonna, just for the sake of changing things up, we are gonna use YMCS mission control system, which also Ricardo mentioned before in his presentation. This system is also vulnerable to an XSS. It's a little bit different than the previous one, because in this case we will have to fish. It would have to be an internal phishing campaign, because the payload is in a configuration file. So we will have to trick the user to upload configuration file to the system, and also we have prepared a small simulation to demonstrate the impact, what you can actually do with the spacecraft. So again, we'll have to fish our user with a malicious payload, and hope that the user will actually load this the malicious configuration on the system. So I will switch back to my VM. Give it a second to start. So again, YMCS, another mission control system with typical functionalities. You have links to the ground station. which right now, because we are running simulation, which we'll see in a second, we have telemetry coming down from the simulator. You can process telemetry packets, parameters. You can send telecommands. For the sake of demonstration, we have, as I mentioned before, we created a simulation so that we can actually send telecommand to spacecraft. And what we have created is, it could be any arbitrary telecommand that is defined in the system, but in our case, again, for the sake of demonstration, we created a telecommand that when sent to spacecraft, it will trigger the orbit transfer maneuver. You'll see in a second, spacecraft is flying around Earth. It's orbiting Earth at the low Earth orbit. So when we send this telecommand, it will transition to the medium Earth orbit. And to do that, we'll use one of the XSS vulnerabilities that is present in the script. It's another functionality that lets you extend the system. So in this, for instance, you can define some more advanced calculations to extend the system to calculate engineering values of based on the raw values of telemetry parameters. And actually, this component is what is vulnerable to an XSS. Here I have an example script where you can see how such script might look like. This is actually taken from the examples that come with IMSI. And you can see here is our malicious payload that is embedded in the script as a comment of a JavaScript, and it's also embedded in the HTML tags. So the vulnerability in the component is that even though it is meant to display JavaScript, if you included the malicious JavaScript in the HTML tags, the web browser behind the web browser engine will actually trigger the JavaScript and not only display the tags. So let's go back to the simulation. Now I can, again, imagine I'm a user. I fell for an internal phishing campaign. I received this script from my colleague, and I decided, or I was asked to load it on the mission control system. Now, if you pay attention on the right-hand side, our spacecraft is still on its proper orbit. But as soon as I open telemetry display configuration, you see that the spacecraft started deviating to the medium Earth orbit. Now, again, this simulation is much faster than real time, so we actually can see what is happening. Normally, it wouldn't happen that quick. But the user currently has no idea that this has happened. They can only see that this was triggered through the telemetry and also through the telecommand history. But at this time, it's already too late because the command was sent to spacecraft. And if you also pay attention to the script, which I open, this malicious payload is not visible at all. And that's because this component is triggering the embedded JavaScript, but it doesn't actually show any HTML tags, which was supposed to be a feature. But in this case, we use it as a vulnerability. So that's pretty much it. We were able to send arbitrary telecommand to spacecraft as if we were a legitimate user of a mission control system with a simple XSS vulnerability. And I will stop sharing and now back to Ricardo.
Yeah, so what we just saw was really just the tip of the iceberg from our own research. We found a big list of vulnerabilities in mission control software, most with a significant impact. So we just saw the OpenC3 Cosmos and the YMCS vulnerabilities combined to have some significant impact. But we also did some vulnerability research on onboard software, again with the same results, finding a lot of vulnerabilities on this software stack. And since then, after we brought some attention that this software stack was vulnerable, other researchers have come forward. So even this list is not already, it's not up to date to the current state of things. So what can you do about it, essentially? What's our defense strategy against this? So this is what we found on open source software. But what about closed source? And when was the last time you actually tested your stack for security vulnerabilities? And does your threat model account for that type of flaw? So basically, every mission should have security and safety trade-off to account for this, and mitigation strategies for existing missions, because at some point you will end up with an insecure mission, and it's not exactly easy to patch software when it's running on space. So space is hard, but space security is not. And at this point, essentially, if your answer to any of these questions is no or I don't know, we should probably have a chat after this presentation to discuss how you can improve that for your missions. And any questions you might have.
Okay, so we have some questions. Question for Pavel. In slide 31, is the satellite to the ground station communication required to use security?
Actually, there is multiple options how to do that, and there is kind of, even in terrestrial network, there may be used IPsec or maybe used some kind of closed infrastructure like fiber optic or radio relay communication. So this is the same. So you can use whatever you want. So that is not stated in specification or stated in optional as optional, because for 3GPP, security is not something what was kind of it is not something which is mandatory or something like that. So they care about working. So the things that they do standardization. So the main target is to make it work. Security is kind of second question, and usually they can write something like, there is no security, so please use IPsec. But if you look on reality, it is not so easy to use IPsec, because IPsec is peer-to-peer communication, and so you have to establish this secure connection from peer-to-peer, so from each one to each one, and this is really hard job, and not always done by operators. I would say usually it's never done. Well, I would not say never, but in most of cases it's not done.
Okay, thank you, Pavel. Now for Ricardo, are these command center systems internet facing usually?
Usually no, not internet facing, but they might in certain conditions be available over VPN. So that's why also we targeted users and not exactly the software stack itself. So the demos you saw, all of them were based around a phishing campaign, either from an internal phishing campaign or targeting user externally, and you could access it through the user essentially, or you could yeah.
Thank you. And the next one for you is this CVE still exploited in the wild?
That's hard to say. As far as we know, no, but it's not exactly the type of information that you have publicly accessible to everyone.
So maybe I can take this one. Hopefully not, because we have followed the responsible disclosure process, and before we made publications and made this knowledge public, we have contacted the vendors for all vulnerabilities, which eventually were fixed. So if you are running the latest version of the system, you are not vulnerable, and hopefully that's what people did. But again, there's no way of knowing.
Okay, thank you. The final question for VisionSpace is, you're saying that a lot of European and American satellites share the same OSS in the spacecraft with a lot of open source software. How is the Chinese situation with the Russian and Chinese spacecraft?
That's not exactly what we're saying here. We focused on software that can be reused across missions, but obviously each mission might have their own stack. As for Russian and Chinese spacecraft, that's not exactly public information as far as we know. So it's hard to say exactly what they are running. Even on European and American satellites, it's not always obvious what they are running. Depends on the mission and level of secrecy that they have. What we know, for example, with CFS is that NASA has been developing that for 20 years now. So it's likely that some of their missions are using it. But it's not a direct link of all of them are running this or anything.
Okay, thank you so much. And that ends us with our webinar. Thank you to our speakers and also the joinee, and we will also share the recording later. Thank you.
Thank you.
Everyone.